All right, looks like we're going. So this is the review for the Chapter 3 test. Just a couple quick notes. There is one section that's on the test that isn't, I mean, it's not exactly like the review, but it's pretty similar. Yep. So anyone else still need a review sheet? All right. But I should note a couple things. One, there actually is a section on the actual test where it's just name the angle pair. Okay, that isn't on the review here, but there will be a name the angle pair section on the test. So be prepared for that. Also, the linear equations on back when we get to it. It's not just parallel and perpendicular. I might also give you 2 points, find the equation of the line, the other types of things that we did. So the review doesn't cover every possible type of problem that would show up on the test, but it covers most of it, and it covers all the major topics. But I'll try to highlight for you what's going to be different on the test, so because I never want you to be surprised with the test. I always want you to know what to expect. Okay? Let's just get through this first stuff. The first problems I think are fairly simple. Name a line parallel to GC. There are several possible answers here. What's one line? What do you got? BF. BF would be just fine, yeah. That was interesting, but okay, great. BF, there we go. And remember, since we're naming a parallel line, we want to use the line symbol, and that's kind of hinted to you in the way that it's labeled on the test itself, yes.
Line DH.
Okay, DH would be another one, AE would be a third. Yep, any of those. How about skew to AD? What do you got?
Line GC.
GC, yeah, that would work.
Oh, darn.
Okay, GC would be an option. There are several other options, BF, GH, FE, all also work.
Not good enough?
No, I'm saying there are other answers that could be there. Perpendicular to FG. Lots of answers here too. What you got? GC would work again. To FG, yep, GC is fine. Again, also, because FG here, she's a GC. Whoa. Might need to reorient here. Hold on. Give me a second. There we go. Try again. There we go. Much better. So GC would work there. We could also do BF. We could also do HG or EF, any of those. Finally, the intersection of the two planes. The planes are ABC and CDH. I suggest always somehow, okay, ABC and CDH, that's this one. Where do those planes intersect? Line DC, yes. It's right there, right on the line. That's intersection. And it's a line, it's not a segment, it's a line, because the planes are infinite, the intersection's infinite also. We also have postulates as when two planes intersect, their intersection is a line, so we have to respect that. All right, awesome. Next is where you would see just name the angle pairs. So just for practice, I'm going to, just for temporarily here, I'm going to put angle 3, 4, 5, 6, and 7 here. So just for practice, what would we call angle 4 and angle 6? What would the name of that angle pair be? Alternate exterior angles. Okay. How about 7 and 2? Vertical angles. Good. How about 3 and 4? 3 and 4?
Well, I was wondering if you're going to have like the names listed as class tested.
I'm sorry?
Is this not going to have the names of the interface listed as like class tested?
No, you're going to have to. No.
Is that for bonding?
What do you call 3 and 4?
Linear pair.
They are supplementary, but the name of the pair is linear pair.
Oh, yeah!
Okay, supplementary is the description of them. They add up to 180, but the name is linear pair. Okay, so just be prepared. I mean, I'm not sure which ones are on the test, but be prepared for that. All right, here it says find the measure of the missing angles and give the reason why. So what would the measure of angle 1 have to be? Measure of angle 1 is 87. And the reason why is the name of the angle pair plus the word theorem, because I already know we're given the lines are parallel. So we're finding the measure of the angle. So what's 87 and 1 make what kind of angle pair? Alternate interior, so alt interior angles theorem. Okay? So again, if this is a 3-point problem, you get 1 point for the 87 degrees. 1 point for identifying the angle pair as alternate interior. And the last point because you're identifying using the theorem, not the converse, but it's the theorem that we're using. It's not the definition, it's not the converse, it's the theorem. We've got the definition of alternate interior angles, which we almost never use other than to name. Okay? The theorem is used when we know the lines are parallel and we're showing what the angle measure is. The converse is what we use when we're proving the lines are parallel. So those three different things. How about the measure of angle 2? 93 degrees. And what's my reason? Between 87 and 2, what do we call this pair? Consecutive interior. Consecutive interior angles. And what word are we going to tack on? Theorem for that last point. Linear pair postulate is a thing, but that is not a linear pair. No, they aren't. Linear pairs are adjacent. These are not adjacent angles. They don't share a vertex. 1 and 2 are a linear pair, yes. But we're always comparing the given angle to the angle, not the two unknowns. Okay? Here. What do we call this angle pair? Okay, so it's going to be corresponding. It's going to angles theorem. Okay, how am I going to set this up? They're going to be equal, right? So 6x minus 11 equals 37. And then we have to do our math. 6x equals 48, divide by 6, x equals 8. Okay? So, pretty straightforward. Obviously, we need to know our angle pairs. But that's not a surprise because we had to know them for the quiz. I've been telling you know your angle pairs for quite some time. Find the value of x that makes it parallel. I didn't ask you to justify here. It's just find the value of x. So we don't need the angle pair, although we can still practice. What do I call these two angles? Consecutive interior. And in order for the lines to be parallel, they have to add up to 180 or be equal to each other? Add up to 180. So 4x minus 12 plus 120 is 180. So that's 4x plus 108 is 180. So 4x equals 72. So x equals 18. Marvelous. How about down here? What do we call that angle pair? What's the name of that one?
Alternate exterior.
Good. Alternate exterior. They have to be congruent or supplementary in order for the lines to be parallel. Okay, here's a hint. If I look at this angle, is it acute or obtuse? And this angle is obtuse. Am I going to add two obtuse angles together and add up to 180? Obviously not. Okay, I can't add a number bigger than 90 to the same number and wind up with 180. It's just not possible. So therefore, they better be congruent, which means I'm going to set those two expressions equal. Now we got a little bit more algebra here. 2x plus 10. So I do have to do some distributive property. And then some combining terms. And I get x equals 44. Okay? But again, really key, if you're going to make an algebra mistake, at least make sure, I've been kind of preaching this all year, always show your initial equation setup. Okay? Always show those. Because if I see those are set up properly, now you've definitely earned partial credit. If you just have a wrong answer, I don't know. And the downside is if you set it up improperly, you're pretty much done. But at least I know where you're making your mistake. And you'll know where you made your mistake. Which lines, if any, are parallel and why? And because they look parallel is not a reason, by the way. Nice try, but no. I want objective evidence. So I've got L, M, N, and P. But the only information I have here is these two angles, the 60 and the 120. I look at that and I see, oh, I see like a letter C. And they do actually add up to 180. And if I see that letter C, that's what type of angles? Consecutive interior. Okay? So, which lines are parallel? Well, if I extend my C, where are my parallel lines? L is parallel to M. And the reason would be consecutive interior angles converse. Good. Okay? Got to get over it. Geometry is a wordy type of math. That's the way it works. And let you abbreviate. Right? I just use the angle symbol. Angles. Okay? That's the abbreviation I'm using. Okay? This one's tricky. This one's tricky. Where are my parallel lines?
L and N, L and Q, M and Q.
Okay, let's start out with one pair and explain why. L and N. Why are L and N parallel?
Right angles and 90.
Okay, let's look at my right angles here, folks. I'm going to draw over a little bit. Okay, I've got a right angle here. I've got another right angle down here. In order for that perpendicular transversal theorem to kick in, I have to have the two lines share one line that's perpendicular to both lines, right? But these two right angles make up four completely different lines. Okay? I mean, I could keep that second one at the blue ones here at a right angle. If I went like this and like this, I could still have a right angle between these two lines. I mean, it's not perfect, but you get the idea. Okay? But now it's really clear that they aren't parallel. It looks like they might be parallel, but don't let looks deceive you. We have to go by facts, not by looks. Okay? Since they don't share a transversal, P and Q are not parallel, or M and N are not parallel by perpendicular transversal. I would have to have this right angle be over here. If the right angle were over here, then I would have L as a transversal and P would be parallel to Q. But I don't have that, so I can't make that conclusion. Okay? What do I have? Besides the right angles, what do I have? I have the 120s, don't I? So I look at the 120s, I have this angle is 120, and that angle. Oh, that's a Z, isn't it? It's kind of a funky Z, but it's a Z. Okay. So what do we have? We have that Z. Oh, I'm sorry. I got the 120 in the wrong spot. My bad. That's better. Sorry, when I copied the picture over, I put it in the wrong spot. Yep, I did. There we go. That's right. It's alternate interior angles, right? So P is parallel to Q by the alternate interior angles converse. Okay, and that's all I have. Yes?
Is there like an abbreviation that we can use for converse?
No. Don't push your luck. Theorem, I'll give you one. Converse, I want the word. Because there's too many words that start with C-O-N and C-O, you know, C-O and C-O-N, complementary, consecutive, converse. We got too many words that start with C. So we're going to write that out. All right, questions on that one? That's a tricky one. The slopes of perpendicular lines are. You got some fill-in-the-blank answers here. You're going to see this tomorrow too. Got to know some definitions. The slope of perpendicular lines are. Nope. Not perpendicular. The slope of parallel lines are the same. Or equal.
No, he didn't.
No. No, he doesn't. All right, the slope of perpendicular lines are reciprocal. Yep, negative reciprocal. Okay, or flipped and negative would be fine. If you don't want to spell reciprocal, that's fine. I don't want to either.
Could we abbreviate that?
Okay, you don't. Okay, so you could say negative reciprocal, negative and flipped. I'd take that. Or you could say have a product of -1 multiplied to give us -1. That's another way you could say it. The slopes multiplied to give us a product of -1. So there are a lot of choices that you have. How about the slope formula? Is M equals what? Yep. y2 minus y1 over x2 minus x1. That's the basic slope formula. It's not y equals mx. It's not slope-intercept form I'm asking for there. Although that could show up in the test. That would be y equals mx plus b. But in this case, it's m equals y2 minus y1 over x2 minus x1. If the slope of a line is undefined, the slope of a perpendicular line must be what? Careful. What does it mean if a fraction is undefined? It means the denominator is, what are we not allowed to have in the denominator of a fraction? I can have negatives in the denominator. Okay. What am I not allowed to have in the denominator of a fraction? A 0. Okay? A fraction is undefined when the denominator is 0. So, since for a perpendicular line I have to flip it and change the sign, but if I flip the 0 goes from the denominator to the numerator. What's the value of a fraction that has 0 on top? 0. So a slope of 0 is perpendicular to a slope of undefined and vice versa. Okay? Find the slope of the line containing these 2 points. This is simply mechanical slope calculation. So I'm not hung up if you do 7 minus 8 or 8 minus 7 on the top. I'm going to do 8 minus 7. Then I have to do on the bottom -3 minus 2. Or 1 over negative 5. If you do it the other way, I get negative 1 over 5, so we get the same answer. The fact that negative's in the numerator and denominator, it makes no difference. They're both negative numbers. So you don't have to do it both ways. You could do it either way. You get the same solution. Write the equation of a line passing through the given point and parallel to the given line. Very important that you pay close attention to this word, if that's parallel or perpendicular, because that's going to make a huge difference in your final solution. But in order to do this, we use point-slope form. And just a reminder, point-slope form is y minus y1 equals mx minus x1. That's the intermediate form that we use because that's the easiest one to work with. We don't have to substitute them once, and then we just do a little bit of algebra, and we're all set. So, this is my x1. This is my y1. That's the points that go in here, and the slope we'll figure out. So we start out by doing y minus the y-coordinate, negative 2 minus the negative is a plus, equals, we're going to do a blank for slope. We'll fill that in a second. X minus the x-coordinate, which is 3. Now I need to know what to put in here for the slope. Yes. Y 1/3. Okay, this line has a slope of 1/3. And since it's parallel, it has to have the same slope. And now we just do our algebra. And 1/3 times negative 3 is negative 1. And one step of addition and subtraction, I get y equals 1/3 x minus 3. Okay? So once I have all my numbers in, I have to do the same 2 steps every time. I distribute, and then I move this number over. It's the same 2 steps every time. The same thing. So we start by filling out, and I go, okay, so y minus negative 5 equals some slope x minus 2. What's the slope that's going to go in here? I got to find it, don't I? I can't just take the 3, can I? Because it's not in slope-intercept form. So I'm going to have to rearrange the equation. You'll be doing a lot of that sort of thing on the test, rearranging equations. So 3x plus 2y equals 18. So I got to subtract the 3x. I get 2y equals negative 3x plus 18. Divide by 2. Y equals negative 3 halves x plus 9. So what's the slope that's going to go in there? I'm parallel, so negative 3 halves. Now I do my 2 steps. I distribute, and I combine terms. So y plus 5 equals negative 3 halves x plus 3. And then I subtract 5. Y equals negative 3 halves x minus 2. So watch, remember, negative times a negative is a positive. 3 halves times negative 2. If you're not sure how to do that, use your calculator. Okay, multiplying a fraction times a whole number, that's something we learned long ago. Same thing, except what has changed? Yeah.
Parallel line is not perpendicular.
Perpendicular line. Oh. So I'm still going to start the same way. Y minus the y-coordinate, which is 3. Some slope, x minus negative 1 is x plus 1. What's the slope of this line? Negative 1/4 is the slope I'm going to have to use. The slope of this line was 4, so we have to be perpendicular to 4, which would be negative 1/4. and add 3 to each side. Now 3 is the same as 12/4. So y equals negative 1/4 x. It's terrible, 1/4. What happened there? Something really wrong happened there. Let's try that again. Y equals negative 1/4 x, and then plus 11/4. Same thing again. Y minus negative 4 equals some slope x minus 1. Is my slope going to be 1? Coefficient of x? No, I got to rearrange it. So x minus 3y equals 12. Subtract the x. Negative 3y equals negative x plus 12. Divide by negative 3. And y equals 1/3 x minus 4. So the slope of this line has to be negative 3. Yep. So y plus 4 is negative 3x plus 3. Subtract the 4. Y equals negative 3x minus 1. There we are. So lots of algebra, right? Lots of algebra. But you guys have been telling me all year how much you love algebra, so, and don't like geometry. That algebra is so much better. All right. Tell whether lines are parallel, perpendicular, neither. If lines are parallel, if there are any parallel lines. What am I going to have to do? I'm going to have to rearrange the equations, right? So 2x plus 5y equals 5. Now let's go with, what color would you like?
Purple.
Purple?
Purple.
Purple it is.
What? They don't get a choice because I'm black?
No. So 5y equals negative 2x plus 5. Divide by 5. Y equals negative 2/5 x plus 1. What are you confused about? Yeah, I know. Just ignore. Okay, for this one, 5x minus 3y equals 2. So subtract the 5x. I get negative 3y equals negative 5x plus 2. Divide by negative 3. Y equals 5/3 x minus 2/3. All right, so I have slopes of negative 2/5 and positive 5/3. Nothing. Nothing happening. All out of work for no result.
Why? Story of my life.
Because the slopes are neither the same nor negative reciprocals. Okay? Okay, so if they're not the same and they're not negative reciprocals, then it's neither parallel. They're intersecting lines at some angle, we don't know what. No, you did find out that they're neither parallel nor perpendicular. This one, same basic idea. A little bit easier. Well, not really. Let's look at it. If I go minus x, I get negative 4y equals negative x plus 8. Divide by negative 4. Y equals 1/4 x minus 2. Okay. This one is slope of 1/4. This is a slope of 4. Are they parallel or perpendicular? No. A and B? Nope. Nothing going on between A and B. Okay. If this was negative, if one of these is negative, it would be perpendicular, but neither one is. Let's try this one. X plus 4y equals 2. So subtract the x. I get 4y equals negative x plus 2 divided by 4. Y equals negative 1/4 x plus 1/2. Okay, now I've got a negative 1/4. That's not parallel to positive 1/4. Is it perpendicular to positive 1/4? No. Negative 1/4, is it parallel to 4? Is it perpendicular to 4? Yes, so B is perpendicular to C. That's the only solution in this case. Could there be more than one solution? Yeah, I could have several parallel lines and perpendicular lines, but in this case, I only have one, that pair of perpendicular lines. So what else could show up besides what we've seen there, because that takes us to the end of this? The other thing that you could see is if I gave you like 2 points, and said find the equation of the line containing those 2 points. So in order to do that, I can still use point-slope form. I got to pick one of the 2 points. Which one do you want to pick, the 3, or the 3, because it's harder to screw things up when the numbers are the same, right? So y minus 3 equals some slope x minus 3. Fantastic. But I do need to know what slope to put in there. How am I going to find slope? Formula, yeah. So 3 minus negative 5 over 3 minus 2. That's 8 over 1. Aha.
Wow.
It actually worked out nice. So y minus 3 equals 8x minus 24. So y equals 8x minus 21. That's the equation.
Was that from the book, or is that just from your head?
I just made it up and got lucky.
Wow. Wow.
It happens. Okay? We just got lucky. So, again, we're still using point-slope form. It's just a different way of finding what the slope is. And we know how to use the slope formula to do that. Okay? I could also just tell you what the slope is in a problem. I could say the slope is this and the point is that. That's even easier still, right? Okay? So there's a lot of different ways that we could set this up. All right. So that's essentially what's going to be on our test. Now, the next thing I need to do, I'm going to stop the podcast.